Hey, good morning, everybody. So I'm Zareen Farooqui. I'm going to be talking to you guys today about breaking into data analytics. So this is a picture of me scuba diving in Palau, just kind of swimming into the infinite blue abyss, which I think is pretty similar to getting into data science in general. So 2 years ago, I was not working in analytics. I was a sales engineer for a software company. And before that, I worked for an electrical manufacturer. Both of these jobs were good, but I was kind of bored with what I was doing. I didn't really feel challenged. And at that point, I thought a lot about what I wanted to do, and I knew that I wanted to get more technical. And to me, that was a mix of programming and math and computer science. But even at that point, I didn't really know what to do. I didn't really know where to start. We have this really good issue in analytics right now where there's so many resources that sometimes for a beginner, you might not know what to do. So at that point, I started researching a bunch of boot camps for analytics. And I just want to point out that boot camps are a business, so at the end of the day, their goal is to make money. That's not to deter you from a boot camp, but if you're interested in doing something similar and getting a new skill and you're looking at boot camps, I would really recommend that you reach out to one or two graduates of that program on LinkedIn or on Twitter and try to just talk to them for a couple of minutes about their experience at that boot camp and just see if they would recommend it and what they thought. It's really important to do your own research outside of what's just on a boot camp website. So I actually did not go down the boot camp route. I decided to dive into a self-study where I quit my sales job and I just spent, full time. I was just learning how to code and learning a bunch of technical topics on my own. On this slide, there's a bunch of resources that are free and online, and they're really good. I didn't use all of them, but I did use some of them. And basically, what I decided to do was spend a few weeks learning a technical topic via books and just online tutorials, and then I would spend some time working on a project where I would just take everything that I learned and actually apply it. And I think when you're learning new skills, this is really, really, really important. It's really easy to just read something and say, yeah, sure, this makes sense. But once you are actually applying it, that's when you know that you actually understand what you've been learning. The goal of these projects was just to make sure that I knew what I was doing and pick something fun that I'd be interested in and actually, would be happy just getting really obsessed hacking on this project. And I also wanted to share my projects with the community. So once I knew that I wanted to get into analytics, one of the first questions that I had was, what programming language do I learn? So in analytics, both Python and R are both pretty popular. And so on this slide here is the TOB index, which is comparing October 2016 to October 2017. This index can be used for figuring out what the most popular programming languages are. It's not used to say, this is the best programming language, or this is the programming language that most lines of code have been written in. But what it does is it pretty much aggregates 25 search engine queries. It uses Google, YouTube, Bing, and just figures out what most people around the world are questioning. So that's the most popular programming language. So here you can see that Python is number 5. Last year was also number 5. R is actually much lower. It's the 15th most popular programming language. And then here's just a couple of really high-level differences between the two languages. So Python is used for a lot of different reasons. It can be used in data analytics. It can be used as a web server backend. You can use it for application development. and R has a much more limited use. It is mainly used in academics and in research, and not as widely as in industry. The Python code repository is called Python Package Index, and there's roughly about 100,000 libraries currently. The R code repo is the Comprehensive R Archive Network, or CRAN, and there's only about 10,000 libraries. And then Python is known to be very beginner-friendly. It has a really elegant syntax that's very easy for beginners to understand, where R has a much steeper learning curve for beginners. So that was kind of like, not as appealing to me. Also, Python makes pre-processing easy. So if you're in analytics, that that like one of the most tedious and time-consuming things that you work on is just cleaning up data and getting it in the right format. Python makes this very easy. Python's also had a very rapid adoption in the past couple of years. So for all of those reasons, I decided to pick Python first to study. So here is a rough guideline that I made for myself to eventually get to a place where I'd be comfortable with Apache Spark. This is just like, a rough guideline of what I made, but here on the left are 3 fundamentals that I think are very important if you want to get to a place where you're comfortable with Spark. SQL, Python, and the Linux command line. The green rectangles are the fundamentals, and then right underneath them is like a rough timeline of how long I spent on them, but this would obviously just vary for everybody depending on where you're starting. For SQL, things like just like joining tables, schema design, and UDFs I think are important. And then, so now that I'm comfortable with these fundamentals, I plan to move on to Spark SQL next. I haven't really started this, so there's a question mark underneath because I'm not sure how long this will take. From there, I plan to move on to Spark Structured Streaming, which is kind of based off Spark SQL, so that's a prerequisite. Also, to get to Spark SQL, I think math fundamentals, so just calculus and linear algebra, are also very important. Just to help you understand like what you're actually doing. It's not just like this random algorithm that you're running. And the math and the Python will lead to scikit-learn, which I think is also really important to get to the Spark machine learning library. Last year, I also got the opportunity to TA 5 Spark classes. The next speaker is my brother, and he was teaching a bunch of these classes. So even though at that point I was not any kind of expert in Spark, I think it was really important to just expose yourself to these other technologies so that while I was learning SQL and Python and command line and all of that, I had this like vision of kind of where these were taking me. So even if you are a beginner and you're learning new topics, I think it's just important to make sure you're exposing yourself to like whatever the next step is, even if you don't really fully understand it. So here is a similar learning path. This leads to TensorFlow. So the 3 computer science fundamentals are the same: SQL, Python, and Linux command line. As far as math, it's basically the same as well. Linear algebra and calculus, which all of that you can use to get to scikit-learn. And then the goal technology here would be that you understand deep learning fundamentals and ultimately TensorFlow. The goal technologies still have a question mark because I'm not at that point yet. But yesterday I actually TA'd my first TensorFlow class as well. So now I want to share a couple projects that I worked on last year while I was learning these technologies. So like I said, one of the first things I wanted to learn was Python. And I was fairly new to programming in general, so I wanted to really start at the very basics. I read this book called Learning with Python: How to Think Like a Computer Scientist. And while I read the book, I coded along the entire time in a Jupyter notebook, all the examples in the book. So this book kind of just went through like the very basics, things like if-else statements and for loops, but I really wanted to make sure I understood those because that's the fundamentals of everything else I'll be doing. So the project that I worked on once I read this book and I felt comfortable with the basics of Python was I did a text analysis of the Harry Potter series. I'm just like a really big Harry Potter fan. This seemed like a really fun data set for me to play around with. And also, when I did this project, I didn't use any natural language processing libraries, and I did this on purpose. There's a lot of great libraries available, but using one of those libraries kind of felt like cheating when my goal was to learn Python fundamentals. Also, I wanted to use at least one external API, Amazon S3 storage, and a visualization engine. And really, ultimately, I just wanted to find some really interesting insights about the Harry Potter series that maybe nobody else in the world has realized so far. So I'm going to share just like a couple of really quick charts with you. This is comparing the total word count to the unique word count per book for the Harry Potter series. You can see that the total word count is much higher than the unique word count, which I think is just normal in all literature, so maybe that's not very surprising. The total word count increases up to the 5th book, and then it kind of drops. I have a couple theories for this. So, as the series is progressing, there's new characters and places introduced, so maybe we just need more words to explain all of that. Also, the books were released over an 8 or 9 year time span, so the average age of the readers was going up as well. So I think I was 7 or 8 when I started reading the books, but I probably wouldn't have picked up a really large book like the 5th book at that time. Next, this is a trigram chart. So a trigram is a series of 3 words that occur in the same sequence. So that blue line is the number of times the words Harry and Ron in that exact order appear in every book. The orange line is Ron and Hermione, and the red line is Harry and Hermione. So the order matters. So the blue line is not Ron and Harry, it's only Harry and Ron. So also, if you've ever read the Harry Potter series, I was always really curious to see if Harry and Hermione would ever date. But doing this text analysis, you can actually maybe predict that Ron and Hermione would end up dating. So I thought that was kind of funny. And this is a custom graph that I made in Keynote, which is basically just PowerPoint for Mac. This is a relationship diagram. So the circles here are characters, and the size of the circle depicts the number of times that name shows up throughout the series. So I used the Wikidata API here to programmatically pull a list of character names instead of hard coding them myself. And then the lines from one circle to another depict the strength of the relationship. So what I did here was, we can take Harry, which is the gray circle in the middle, and Snape, the top blue circle. So you can see that there's a really thin line going from Harry to Snape, so it's maybe not as strong of a relationship. And then there's a really strong, bold, thick line from Snape to Harry. So first of all, this kind of makes sense because Harry's the main character. But what I did to find this was I took every instance of the word Harry in the series, and then I looked 40 words left and 40 words right, and counted the number of times Snape shows up, and compared that to the total number of times Harry shows up. So this is not any kind of exact science for relationship strength, but it was just a fun question that I wanted to answer and do a unique analysis of. So every character's relationship to Harry is much stronger, and that makes sense since Harry's the main character, so he's in almost every scene throughout the book. So when Harry's around, Snape's only there part of the time, but when Snape's there, Harry's there almost all the time. And I was making the assumption that if a name shows up within 40 words of each other, that means that those characters are either physically in the same space or at least talking about each other, and that should strengthen their relationship. So next, I wanted to get into some web development and also a little bit of machine learning. So the next project that I did, I built a front end and back end completely from scratch to showcase a machine learning algorithm called Word2Vec. I used a bunch of tutorials from W3 schools to kind of like figure out how to do this. I used AWS. I was storing my data set on S3 and running an EC2 server in the cloud to host my web app. And then I used the GenZim open source Python library to build and evaluate my Word2Vec model. And I used the Bottle micro web framework. And then I also used SQLite 3 in the background as my database engine. So, you know, similar goals. One thing I wanted to do for this project was make it interactive to the public. So I'm just going to do like a very high-level overview of how Word2Vec works. It takes a text corpus, a bunch of text, it breaks it up into sentences, it turns those sentences into vectors, puts it in a vector space, and runs a cosine similarity on those vectors to figure out how similar words are. So in this example, I have just two example sentences. The first one is, Harry is a wizard, and the second one is, the greatest wizard is Dumbledore. So the second like little parentheses is my text corpus. So that's every word that's in both of those sentences. So to turn the sentence into a vector, I would take like the entire text corpus and either give it like a 0 or 1, depending on if that word was in my sentence. So in the first sentence, A does show up, so A is 1. Dumbledore doesn't show up, so it's 0, and so on and so forth. And as far as cosine similarity, so this is how Word2Vec evaluates how similar words are. So the example on the left here, these two words, Gryffindor and Slytherin, they're pretty similar. They're both houses at Hogwarts, which is the school that Harry goes to. The angle is closer between those two vectors, which means the cosine similarity is higher. Cosine similarity can be between 0 and 1, and the closer it is to 1, the closer those words are. So I'm actually going to do a really quick demo of my project. Okay. Somebody that has read the Harry Potter series, can you just throw out like a word that shows up like at least 50 times in the series? Anybody? Okay, I'll go with like Hogwarts, which is the school that they all go to. So when I click enter, it's going to run this. The 7 most similar words to Hogwarts are school, makes sense, tournament, Gringotts, a couple other words. It's ranked by how similar the words are, so the top word is the most similar, and so on and so forth. So if I enter a word that's not in the series, so like my name is not in the books, if I do that, it's going to say Zareen's not found in the 7 Harry Potter books. If I put in another word, let's try like, what's that? Malfoy? Sure. These are all characters also, so you know, it's saying like these are the 7 words that are most similar to Malfoy. Cool. Then okay, to go back into this. So my front end is being run on Namecheap, and then, you know, as a user enters a word, you're served this results page, and then from the results page, you can just keep looping through words. So once a user enters a word, my word-to-vec model is running in the background, and it serves the 7 words that are the most similar. However, if so what it will do then, it'll store those results in my SQLite engine, and the next time another user is coming to this page, if they type in the same word, instead of running the algorithm again, it's just going to serve the results from the database. So it'll be a little bit quicker. And then this is like just a last quick project that I want to share with you. The 2 projects before were more like, like the web development project wasn't really analytics, so I wanted to kind of dive back into analytics. I knew I wanted to learn the Pandas Python library because I think that's very crucial for analytics. And then I watched a bunch of Pandas tutorials from this dude whose picture I have on my slide. He has a bunch of tutorials on YouTube, and they're really great. So if you're interested, I would recommend checking them out. And I used Wikipedia clickstream data for this project. And I did this project in the summer of 2016, so this was before the US presidential elections. But I wanted to analyze traffic to the candidate Wikipedia pages and look at maybe some social media trends. So first of all, this is March 2016 Wikipedia page visits for every candidate that was still in the, running in the election at that time. This is really crazy. Donald Trump has more than 10 times as many page visits than the next leading candidate. That's just like pretty insane. And actually in 2016, Donald Trump's Wikipedia page was the #1 visited Wikipedia page. Next, this is a Sankey diagram, which is showing April 2016 incoming and outgoing traffic to these 3 candidate Wikipedia pages. So the gray line depicts the amount of volume going in between the articles or the nodes. And so you can see that like the Democratic Party and the Republican Party and just like the US presidential election page didn't really drive a ton of traffic to the candidate pages. I also thought it was just really interesting that once a reader got to the candidate page, the #1 article that they clicked out of was that candidate's significant other. So it wasn't anything like policy related. People just want to know about people's personal lives, I guess. And then this is looking at March 2016 Google, Facebook, and Twitter traffic to the candidate pages. You can also see just that like Google drove a ton of traffic to Wikipedia here. It almost looks like Facebook and Twitter drove no traffic to the Hillary Clinton or the Bernie Sanders page. That's not true, but so much traffic was driven to the Trump page that it just like you can't even see it in this diagram. So last year, after spending a few months just like working on these projects on my own and like learning Python and working on learning a bunch of random technical topics, I felt like I was ready for a full-time job, and I started looking and applying to jobs in Boston. I actually ended up doing this Outreachy internship first. So Outreachy is a program that offers 3-month paid remote internships to women and minorities in the technology field. And it links these interns with free and open source projects from all around the world. And most of the internships are around software development or data science and documentation. And it also connects each intern with a mentor at that organization that you like talk to about your project work and is guiding you through the technical projects that you're working on. These are some of the organizations that are currently offering Outreachy internships for the next round, which I think starts in December. They're really great organizations, and if you're interested, I'd be happy to talk more about this experience. But you can learn more if you just go to the Outreachy website as well. So I ended up doing an internship with the Wikimedia Foundation, which is the nonprofit behind Wikipedia. I worked with their reading department, and the goal of the reading department at Wikimedia is to understand user needs and understand how readers from across the globe are consuming Wikipedia content and find ways to make this faster and better for users. This is done across all platforms and all language editions of Wikipedia. So one of the projects that I worked on during my internship was creating these monthly readership reports. And the goal of these reports was to raise awareness about metrics that are developing and call out any unusual events that might be happening and just facilitate thinking about these metrics in general. So this is a chart that shows daily page views to Wikimedia. You can see that there's about 500 to 600 million daily page views. And here you see like two small bumps. So Wikimedia sites experience this slump and bump around like the winter holidays. So desktop engagement really declines and mobile engagement increases. And I think this makes sense. You know, people are on holiday, they aren't at their work computer, they might just be on their phones more. The second red rectangle here is the past holiday season, so it's like Christmas 2016. This is kind of interesting because from December 26th, 2016 to January 1st, 2017 was the first full week where mobile engagement was consistently higher than desktop engagement. So that's kind of exciting for Wikimedia. So here's another project that I worked on. This was a project to investigate the 100 most frequent article headings on 5 large Wikipedias. So if you have ever been to a Wikipedia site, which I'm sure everybody has, each article has like different section headings, you know, like career, plot, early life, things like that. This came as a question from the reading department. They were trying to figure out how many articles had a See Also section. So to do this, I wrote Python code in Pause. And Pause is basically a Jupyter notebook that's provided by the Wikimedia Foundation. It's like a web-based notebook. And the point of Pause is to remove all of the added redundancies and just make like a really quick environment where you can program and publish your results and have easy access to the open data that the foundation releases. So I think Pause is still in beta, but if you're interested in it, if you have a MediaWiki account, which anybody can create, you can test this out as well. These are results for the English, French, German, Italian, and Spanish Wikipedia. There's a lot of similarities, but I won't go too much into that. I also worked on a retention metric. So this was a new metric that the foundation is developing. It's a privacy-friendly metric to understand how often users are coming back to the site. And it uses this new metric that they introduced last year, which is a unique devices metric. And I also started initial work on an engagement metric, which is to understand how long readers are engaging with Wikipedia content by looking at the amount of time they have an article open in a browser window. So this internship ended in March 2017, and then in April of 2017, I started my first full-time analytics job. So right now, I am a business intelligence analyst at Wayfair, and Wayfair is an e-commerce website that's based in Boston that sells furniture and home goods. So the analytics department at Wayfair is about 120 to 130 people. That's split between about 90 to 100 business intelligence analysts and then about 30 data scientists. This was actually really important to me. After spending a long time just like working independently at home and like having to Google everything myself, I really wanted to work at a company that was at least medium-sized and a company that had a fairly large and robust analytics department, especially for me coming in as like, you know, a new person in this industry. I really wanted to be around more senior analysts that I could learn from. So at Wayfair, each analytics team aligns with the business unit, like marketing or operations or web analytics. I work within our marketing department, and I work on the notifications team. So I'm analyzing email marketing data, transactional email data, text messages, and also app push notifications data. So the analytics department at Wayfair uses a ton of SQL and also some Python. And now some of the work that I do is things like creating and maintaining Tableau reports, completing some ad hoc data analysis requests from our business stakeholders, and also developing OLAP reporting technology, so like cubes and MDX. Cool, so I'm gonna also just go into just some like general advice that I have for anybody else that's interested in doing something similar. So my first piece of advice is to work on projects and share them. This is just super, super, super important. First of all, you have a portfolio that you can show others. So at any point when you're like interviewing for new jobs, you're not just saying like, yeah, I know Python, but here's this like entire portfolio you can show of all of your work that you've done. And also sharing your projects, I think, is really important to just build credibility. And also, you're helping other people who might be in that similar position at any other point in the future. So I think that's like a really, really big piece of it. Next, find a technical mentor. So this is also really important when you're new and like you keep like running into issues and you might get frustrated. It's really good to have somebody you can like bounce project ideas off of or just get some career advice and just talk to about what you're doing and talk to about what they do. Next, go to and present possibly at local meetups and ask to get coffee with contacts. So obviously this will kind of depend on where you live and what the technical community there looks like, but I live in Boston and there's like a really thriving technical community. There's all sorts of meetups and groups, and I went to a ton of meetups and just like talked to as many people as possible to see what they do at work, like how they like their jobs, like what they want to learn, what they know. And like my current job that I have right now, I actually went to a meetup and there was a data scientist presenting from Wayfair, and I really liked her talk, so I talked to her after, and I asked her to get coffee with me, and I met her up a couple weeks later and just like had a really casual conversation, and I told her what I was doing and got some advice from her. And at that point, I was not looking for a full-time position, but then a couple months later when I reached back out to her, and she actually gave me like some advice on my resume, and she referred me to my current position at Wayfair. So you never know who you're going to meet, and if you're like learning something new, I just really recommend trying to network as much as possible in your community with people who are in that position. Next, learn how to ask better questions and try the rubber duck method. So I think asking good questions is a really underrated skill, and like it's totally okay to also ask bad questions, but I have some advice for like asking better questions. So if you're stuck on something, first of all, obviously try to like Google it or do some research on your own. That isn't always going to answer your question, but at least then when you go to somebody else and you have a question, you can already tell them what you know and what you've already learned and what you think maybe the issue is, but you're not really sure. Make sure you're asking the right person a question. So, like at work, it might not be the most technical person or the most senior person that you need to ask a question to, because that person might just be really busy and like not have a ton of time to answer your questions. Like maybe you just ask the person who sits next to you who's just slightly more experienced but can still help you. So another thing is like try the rubber duck method. So this is something where if you're stuck on a problem, instead of like just immediately going to ask somebody, you can just like lay out the entire issue you're having, everything you've tried, and just say it to yourself. So you don't even have to say it to anybody, like you just literally pretend like you're talking to a rubber duck. And once you're logically explaining that issue to yourself and you're like talking about everything you've done to troubleshoot it, you might find that you just answer the question yourself, because that happens to me a lot, and I think it probably does to a lot of other people. And then This is more advice for when you're looking for a job. Focus more on gaining skills and less on the job title. So I don't think there's really any consensus right now in the industry about what is the difference between like a data analyst versus a data scientist versus, like a data engineer. It's not really apparent what those exact positions mean. So when you're looking for a job, I would say like look at the skills that job requires and make sure what you want to learn and what you would like to know are the skills that job requires more so than the title. When I was learning on my own, I just made sure to constantly be checking like local analytics jobs in Boston because I wanted to make sure that what I was learning was what the jobs that I wanted, those were the same skills. So I think like, don't really worry that much about your title, especially if it's your first technical job, but just make sure you're learning technology that's going to set you up for every other, career move that you make. And now I have just some like also general manager advice. So this is advice for people who might have direct reports who are trying to learn new technical skills or, get into data science. So the first thing I have here is to create an environment where it's okay to say, I don't know. So this really comes from the top. So senior engineers and senior analysts have to feel like it's okay for them to say they don't know when somebody else asks them a question. Like when I ask somebody a question, if they don't know, I would just much rather they like tell that to me rather than like make up some sort of answer. And in that scenario, like the best, most ideal situation is that they say, I don't know, but let's figure it out. And we can like research this question together. And I'm also learning how to learn instead of just being told an answer. I think that's a lot more valuable for me than just being told what the answer is. Next, clearly define an escalation path for technical roadblocks. So when you get stuck on something technical, it's really easy to just be like stuck for a really long time and get really frustrated. To avoid this at work, I think there should be like, specific, either like a mentor or somebody on your team or like a specific team you can go to for technical questions. This could even just be as simple as like a Slack channel for the whole department where anybody can ask or answer questions. And that way, like just one person isn't being bombarded with questions, and this gives an opportunity for more junior people on the team to answer any questions that they might know the answer to as well. Next, drive focus on creating a learning environment and developing new skills. So a really famous example of this is Google's 20% time, where Google engineers or Google employees are allowed to spend 20% of their time at work working on personal projects. So I don't think this is like as widely used at Google anymore, but something similar to this where, it's encouraging employees to learn new skills and like maybe answer questions in a new and creative way is really helpful. Another thing is to have lunchtime technical talks. So this could be like work projects that you're talking about, but this could also just be totally random, interesting technical topics that anybody would be interested in learning about. So like, I don't know a ton about Bitcoin, but I'm interested. So maybe like I could just take, some free time in a week to learn a little bit about this and then put together like a quick 15-minute presentation that I can share with my coworkers, and everybody gains a lot there. Next, encourage cross-department collaboration without managers present. So this is just a way to learn from other people at your company, learn about what other people are doing, and have just the opportunity to ask them questions without having to go through management first. And then the last thing I have here is develop feeder programs. So these are programs where they're entry-level positions for people trying to get into analytics, for example, but they might not have that experience, but if they show competence for those skills, you could still hire those people and train them these skills. And I think these are also really good for like cross-department movement. So, if there's somebody in marketing that's really interested in analytics, they already work at that company, you already know that they've like gone through that interview vetting process, and instead of like them having to just like totally learn everything on their own, there's ways to like set up these programs internally where you can teach them the skills and set them up for success in a new role that they'd be more interested in. And then I want to touch on one last thing before the end of my talk, and it's imposter syndrome. Because I think that this is something that a lot of people deal with, especially in the technical field. So there's this blue bubble here that says what I know, and it's inside this much larger pink bubble that says what other people know. So these are images from this really great blog post by Alice Liu. She has a series of posts on imposter syndrome. So like learning anything new is really difficult. Learning how to program is really difficult. It can feel really overwhelming a lot of the time. But if you don't feel overwhelmed, you're not really learning a lot. So you should feel this way. And, this is not imposter syndrome. This is reality for every single beginner. You can't compare yourself to somebody who's been in the industry for 10 years because obviously they just know a lot more than you. That's not an issue. Like, that's not a bad thing. So here on the left is actually what imposter syndrome is. It's this little blue bubble that says what I think I can do inside this larger pink bubble that says what I can do. So imposter syndrome is actually a psychological phenomenon where you are incorrectly assessing your skills. So imposter syndrome is somebody thinking they're like a 3 in programming, but in reality they're a 7. So on the right here is overconfidence. So this is, this like small bubble of what you can do versus what you think you can do. I think our current work culture just like really values overconfidence and rewards overconfidence, and that's not a good thing. So you don't want people of low ability to just think that they're better, like to incorrectly be assessing themselves. So that's not the goal here. Just like simply feeling more confident about your work is not the answer here to getting over imposter syndrome, and that's not helping anybody. Instead, I think getting over imposter syndrome is really resetting your mindset to realizing that what you know is just different than what other people know. So it's not like better or worse. And obviously, this isn't the case for beginners. Like, this isn't, like, if you're just starting a new skill, this is maybe not, like, super relevant. But as you're progressing, it's just important to realize this. So that's all I have for you guys today. Thank you so much. I think we have time for a couple of questions, but I'm also on Twitter and LinkedIn. If you have any questions or feedback, I'd love to hear it. If any of the projects that I talked about were interesting and you're interested in like recreating anything like that yourself, I have really detailed blog posts about how I built everything and all of the decisions I made, so you can check those out. And there's also links to my code, and it's all on GitHub, so feel free to use it and recreate it for your own stuff. Thank you.
Thank you. Can you go over here?
Okay.
Zareen, thank you so much for your speech. So, we have some questions for you. So, first one is, how much of your time did you spend with learning? And what does 3 months mean? Only learning a full day, 5 times 8, or only part-time? 5 to 8 or only part-time?
Yeah, so like I said earlier, I had actually like quit my job and I was like diving into this full-time. So for me, that 3 months means I was spending like all day for basically like, I treated it as like having a full-time job. Like I think that was really important because I had to be really like self-motivated. I couldn't just like wake up at like 1 p.m. and just do whatever I wanted. I basically like spent the same amount of time I would have just like a normal job studying full-time. So yeah, 3 months means like basically like, from like 9 to 5, like 5 days a week, I was like studying that topic or just like learning those fundamentals.
Okay, so R has sleep investment to learn over Python. Lots would argue the opposite, 0. could you explain on that?
Yeah, definitely. You know, like this is a really like popular debate in analytics. I think it is a personal preference, first of all, like whatever you think is easier, like that's not a science. Like I can't say for sure, absolutely Python's easier. That'll just depend on what your specific background is, what you already know, where you're coming from. I personally like did learn a little bit of R in college, and I did not like it. It was like much harder for me to understand what I was doing. And when I look at Python code, I can read it and like very quickly understand what it's saying and what I'm trying to do. So sure, lots would argue the opposite. You know, I think that that's totally true. I think it's a personal preference. Like I said, I also picked Python just because I felt like that was a lot more like used in industry, and especially like in Boston, just like if I could say that I knew Python on my resume, I felt like that was going to open up a lot more doors for me than R. I feel like if you're learning R, like it's like you can use that for analysis, but Python also has a lot of other use cases that you can transfer those skills much easier than just learning R. So I hope that answers.
All right, great. So, as a beginner, how do you know when you reach enough knowledge for a real job? So, did you get any external feedback on your progress?
Yeah, that's a really difficult question as well, because you never like learn everything, right? Like there's never a point when you're like, oh, I know every single thing about Python, I'm good, like I'm done here. That doesn't happen. That's never gonna happen. Like that's not a real expectation at all. Knowing when you know enough, you know, like there's not a really good answer to that. It's just when I felt like I was comfortable. Like I didn't have to Google every single question. I wasn't just like constantly frustrated with what I was doing. And I felt like I understood what I was doing and what I was working on. As far as external feedback, yes, definitely. Definitely, this is important. And that doesn't even like have to be like, oh, this is my mentor, I'm gonna show him or her my code. It could just be like sharing your projects in blog posts on the internet. And even if you feel like your projects aren't like good enough or technical enough, like people on the internet comment and write things, and they might just give you feedback of like, well, why did you do this instead of this? And they might bring up points that you didn't talk about or you didn't think about. And they might, you know, give you ideas for like adding more to your projects. You know, like knowing when you've reached enough, it's just like once you feel relatively comfortable, I'd say, like you're never gonna become an expert in any topic. So it's kind of like realizing like, okay, I know enough Python that I feel comfortable. Like I don't want to focus all my time just on this, but I need to move on to something else. Like I need to learn another skill as well.
Brilliant. Thank you so much for answering those questions and for your speech. So we have a lovely, we have a lovely picture of you.
Thank you.
Thank you again, and enjoy the rest of the conference.
Awesome.
So let's give a big hand for Zareen.